Thank you so much for joining this lesson. Today we're going to discuss the Kenya National Maths Guru Examination Council, whereby we are presenting the paper 1, section 1, 2025. So later we will schedule a lesson whereby I will discuss the section 2 of the same exam. This is a very wonderful exam and I invite you together with your friends so you can share this broadcast. Just click the share button and invite a friend through the link to this video. I also request you to subscribe to our platform for more notifications whenever we are having a program. Section 1, we're going to do the 50 marks, all of them. As we begin the paper, let me create some awareness here of a very wonderful mathematics contest which has been organized and planned by the Machakos School. This one is in the surroundings of Machakos town. So from Nairobi, Machakos School is as you enter the Machakos town. So this is a wonderful program and we invite you together with your school. If you're in need of this letter, you can inbox the stakeholders or the planning committee, which is headed by the HOD, Mr. Kiminza from Machakos School. So any number here is going to share the letter to you. Then from that, you can print it out so that you may present to the administration. I know some teachers are listening to us. I know some students are listening to us. You can inquire for this letter. And from that, we shall have a wonderful day together. That is the 10th of May, 2025. So welcome all, invite a friend, invite a school, welcome teachers, welcome students so that we may interact and have to grow together in this subject called mathematics. See you at Machakos, 10th of May, 2025. Thank you so much. Number 1, without using mathematical table or a calculator, evaluate 6.5 divided by 1.5 plus 1 3/4 of 2/3. Then out of 2 1/3 minus 2 multiplied by 1/3. All right. So let's now proceed with this. Let me begin by analyzing the numerator first. Then later, I'll check the denominator, after which I will look at the combined solution now. So from the numerator, according to board mass, we can see that there are brackets already. So we deal with what is inside the brackets. So outside the brackets, we have a 13/2. I'm changing the mixed number to an improper fraction. This one is divided by, now inside the brackets, we are having 1.5, which is 3/2, plus this one is 7/4, then of 2/3. From here, we can solve what is inside the brackets. Remember, 7 is over 4, sorry. 7 out of 4. Yeah, that way. So 3/2 and 7/4. When I add that, I'm getting exactly 13 out of 4. So I'm having 13/2 divided by 13/4 of 2/3. According to board mass, I'm supposed to handle the of first. So to deal with the of, which is treated as a multiplication or product, then it means I'm having 13/2 divided by 13/4 multiplied by 2/3. That way. So I'm going to deal with that part first. To wind up with the numerator, I'm supposed to have 13 out of 2. Then this I'm dividing by, this is 2. So I'm having 13/6, right? 13/6. With this now, we can handle the division, whereby 13/2 should be multiplied by the reciprocal. And this is going to give us exactly 3. So from the numerator, the answer that I'm getting is 3. Let me check the denominator now. We have 2/3. Okay, 2 1/3. You know, 2 1/3 now can be converted to an improper fraction instead of a mixed number. This becomes 7 out of 3. Then 7 out of 3 minus negative 2 should be multiplied by a third, which becomes negative 2 thirds that way. Negative 2 thirds. And when we solve this, we shall have 5 over 3 that way. So from the denominator, this is now the denominator, we are getting 5 out of 3. Now with that, we can get the final answer whereby we combine the numerator and the denominator. So this way, I'll have to take 3 and I divide it by 5 over 3. This is going to be 3 multiplied by 3 out of 5. You see, we are getting 9 over 5, but we cannot leave the answer as an improper fraction. So we make it a mixed number, which is going to be 1 and 4 out of 5. Yeah, 1 and 4 out of 5. So that is the final answer for number 1. We have a wonderful question in number 2. Without a calculator or mathematical tables, evaluate or solve. Of course, now we are solving for x. This is a question from indices. We shall apply a few laws of indices. Whereby, because I can see we are having composite numbers throughout on the left-hand side, we can express them to the least possible common base. The least possible common base. So we factorize all the composite numbers that we can see here to base 2. So 4 becomes 2 power 2. Then there is power x here. This one is multiplied by, you know that 2 is already, we are already obtaining square root at that point. Then after obtaining square root, we are raising to power x. Let me interpret this information in a different way, whereby I'm supposed to apply the fractional law of indices that says when you are having a number, let's say a, raised to a fractional power, like m power n, this one should be solved by taking the nth root of a. Then everything is raised to power m. So I'm going to apply this law now in the reverse side, such that I will start by writing 32 and x over 2. Yeah, 32 and x over 2. So it is 32 and x over 2, which I'm supposed now to express as a base 2. So that 32 should be expressed as 2 power 5. And now we are already having x over 2. So that 2 power x over 2 becomes 2 power 5x over 2. Yeah. 5x over 2 is a power already. This one is being divided by 256. This one is the same as 2 power 8. Yeah. So 2 power 8. So it should be 2 power 8. Then there is already 1 over x there. So it should be 8 over x as a power. This is equal to, there is a law that we call the zero index, which says that anything power 0 equals to 1. Any base raised to power 0 should give us 1. And that applied, it means we can change 1 to 2 power 0 that way. Now you see, we have introduced base 2 throughout the expression or throughout the equation. Now at this point, we can apply some more laws of indices, whereby we will say that because the base is the same throughout the equation, from the numerator we can add the powers, because we say a raised to power m multiplied by a raised to power n. Because the bases are the same, we just take a and we add the powers. So we add the powers, 2x, then 5 over 2x. So 2 plus 5 over 2. You know, 5 over 2 is 2.5. When we add 2, we get 4.5. So this is 2 power 4.5x. Then this has been divided by, divided by 2 power 8 over x. This is equal to 2 power 0. That way, that's equal to 2 power 0. So at this point, allow me cross multiply, though we can still have the powers that point, we can have the power subtracted, but allow me cross multiply such that I'm having 2 power 4.5x. This is equal to 2 power 0 multiplied by 2, 8 over x. So on the right hand side now we can have 2 power 8 over x, because we are multiplying it by a value which is equivalent to 1, or simply we are taking 2 and adding the powers, whereby 1 power is 0. That way. So at this point now we can equate the powers. Yeah, we can now equate the powers, whereby we will be talking about 4.5x being equal to 8 out of x. Yeah, at such a point now we can multiply through by x, so that 4.5x, when we multiply by x we get squared, and this is equal to 8. So how can we remain with x? That shall be x squared, of course. So x squared equals to 8 divided by 4.5. This is giving us exactly 1 and 7 over 9. 1 and 7 out of 9. You know, this is equivalent to 16 over 9. Yeah, 16 over 9. So for us to get x, we need to get the square root now. So the square root is giving us 1 and a third, or simply 4 out of 3, which is 1 and a third. And remember, when we take square root, the answer can either be plus or minus 1 and a third. So that is the value of x. So we are having the value of x over here. That is it. We can check number 3. Namanda uses a third of his farm for planting coffee, a quarter for planting tea, and 2 out of 5 of the remainder for mixed farming. He still has 6 acres of land unused. Determine the size of Namanda's land. Let's assume that the whole land is x. The whole land is x. So we have now talk about a third x, a third of the land, a third of the land. When we add a quarter, a third, and a quarter of x, what does this give us? A third and a quarter. This gives us 7 out of 12. So 7 out of 12 of x. This one has gone to coffee and tea. So coffee and tea takes 7 over 12 of x. Remember, x is the total land. So what is the remaining portion now? The remaining so far is 5 out of 12, because 7 over 12 have already been used for coffee and tea. Then we remain with 5 out of 12 of x. This one now is the remaining, and that's why we are saying 2 out of 5 of this remainder goes for mixed farming. So 2 out of 5 of 5 over 12 x. This one goes to mixed farming. So when we take 2 out of 5 and we multiply this by 5 out of 12, this is giving us a 6th x. Yeah. So a 6th x is the one that goes for mixed farming. With that now, we can talk about the used land so far. Used land so far is going to be 7 out of 12 x and a 6th of x. So a 6th, we add 7 out of 12. This takes us to 3/4 of the land. So 3/4 of x has already been used for both coffee, tea, and mixed farming. Now, That means the exact remainder now, the unused so far, unused land is going to be x minus 3/4 of x. This gives us a quarter x. So a quarter of this land has been provided as 6 acres. A quarter x equals to 6 acres of land. What about x itself? If a quarter of x, if a quarter of x equals to 6, then what about x, the whole fraction now? It shall be 6 by x divided by a quarter. Not dividing by a quarter means multiplying by 4 over x that way. This is x over 4 equals to 6. What about x itself? So this is going to be 24 acres of land. That is Namanda's land, the whole of it. So that is the size of Namanda's land. Yeah, that is it. So thank you for being attentive. Remember to subscribe. Remember to share so that you may invite a friend as we continue learning together. Now we got a number 4 here, which is a question on commercial exchange rates. A tourist from the UK arrived in Kenya with 5,000 sterling pounds and exchanged the money through an agent at a commission of 1.5% using the exchange rates below. So we have the exchange rates shown in a table there. While in Kenya, the tourist spent 250,000 Kenya shillings on accommodations and traveling. He had to pay tax of 13% of the initial amount of money before leaving Kenya or United States. How many dollars did the tourist leave Kenya with? A very interesting question, which is having a lot of instructions. And here, a student is supposed to be very careful. Very careful. So you can follow through now as we work it out. This gentleman is coming with 5,000 sterling pounds. This is a foreign currency. So coming to the bank and the gentleman needs Kenya shillings, the bank has to buy. The bank buys the sterling pounds from the tourist. And how does the bank buy the sterling pounds? 1 sterling pounds goes for 135.50 Kenya shillings. Therefore, because he's having 5,000 and the bank is buying each at 135.50, how much Kenya shillings will he receive? Or how much Kenya shillings is worth this amount? So we talk about 5,000 multiplied by 135.50. This is going to give us 677,500 Kenya shillings. But now something you're supposed to know is that the tourist is not going to receive this amount. At the bank, somebody requested for something small to help him in converting very quickly. Somebody went to this Muzungu and told him, you see what? Don't stay in the queue. Give me 1.5% of what you're having so that I help you in converting very quickly. So in that process, he had to give out 1.5. So from the total amount, 100%, when we subtract the 1.5, we find that he received 98.5% of this amount. So the amount he entered Kenya with now, from the bank now, from the bank is going to be from the bank is going to be 667,337 and 50 cents. So that is the amount he's going to receive from the bank. Yes. After this now, we are told that the guy is being taxed and the guy is also spending some money. So total expenditure is going to be the tax paid and also the amount used on accommodations and traveling, so that you may get the actual balance, which is going to be converted to the US dollars. So tax. So after tax, yeah, let's get the tax. What tax? What amount of tax did he pay? 13% of the whole amount that he is having. Yeah, 13%. So this is going to be a tax of 86,753.90. So this gentleman paid tax to the Kenyan government, that amount. It means we can get the real remainder now. Remainder shall be when we take 667,337.50 and we subtract the amount which has been spent, 250 for accommodations and traveling, then 86,753.90 for tax. So the real balance shall be, so I take 667,337.5, we subtract 250,000 and 86,753.9. So this is going to give us a balance of 330,583.60 Kenya shillings. So this is the balance the gentleman is having by the time he's now planning to go back to or to travel now to the US, the United States. So now he is going to the bank and he needs US dollars. So the bank is going to sell US dollars to him because he's having Kenyan shillings and the bank is in Kenya. Then we're going to talk about the US dollars that this gentleman is going to receive. So we will talk about now the bank selling to him US dollars. The bank sells $1 at 101.3 and he is having 330 583 Kenya shillings. So how much US dollars is he going to receive? How much will he be in a position to buy? Because the bank is selling to him. So we take 330,583.6 and we divide by 101.30. We will know the amount of US dollars this gentleman is able to buy from the bank because the bank is selling to him. So this now becomes 32,63.40 US dollars. So that is the amount in US dollars the tourist is going to travel to the US with. That's simple. So you should be able to play along with this language. You see there is commission involved. This time around, there is tax to the amount the gentleman is going to receive and all that. So make sure you evolve with instructions. Evolve with instruction. Don't receive new instructions and you start saying, this is a new question that we've never seen. No. Can you be ready to adapt depending on questions? Number 5, given that 6, the cosine of x plus 15 minus 6, the sine of 2x minus 30 equals to 0, find the tan of 2x minus 10, leaving your answer in SAD form. Now this one is a trigonometry and also some part of SADs, which is a paper 2 concept. In form 2, you learned about complementary angles, whereby these are two acute angles, which when added, they give us 90 degrees. And there is something we know about them. Their sine and cosine are always equal. In other words, the sine of an angle is equal to the cosine of the complementary angle to that one. So with that, we can approach this question. Actually, I would tell you for free, whenever you see cosine and sine used in one equation or one expression, and we are not having any of them squared, then just know that we are dealing with the rule about complementary angles that says the sine of an acute angle equals to the cosine of the other acute angle where alpha and beta are giving us 90. This one is the rule in application. Whenever you see sine and cosine in their simple state without any of them being squared. When one is squared, then we will talk about a different trigonometric identity. But for now, this is what we have. So now we have to talk about it. 6 can divide through, or even we can start by saying 6, the cosine of x plus 15 equals to, the other 6 goes to, we take that other portion, the term to the right where it becomes also positive, sine 2x minus 30 that way. So you see 6 can simplify out very simply. And then our rule now applies. So if cosine of x plus 15 equals to the sine of 2x minus 30, then it is a clear indication that x plus 15 plus 2x minus 30 should give us 90. So with this, we can talk about 3x equals to, this is negative 15. 15 minus 30 becomes negative 15. So 15 now should be added to 90. That gives us 105. So that the value of x now becomes, when we divide through by 3, this becomes 35. With this knowledge now, we can go to tan of 2 by 35. Then we subtract 10. This becomes the tan of 60 degrees because of 70 minus 10. Then with this, we say that tan of 60 in third form equals to the root of 3. That's simple. We studied tangents, cosines, and sines of special angles like 60, 30, and 45. So the tan of 60 equals to the root of 3. So square root of 3 is 1.732. And the tan of 60 is also the same. So that is how you work it out. You express the tangent in third form. Remember to subscribe. Remember to invite a friend to the platform so that they may continue learning something with us. Look at number 6. And by the way, as we continue learning, I would like to ask you, how have you been recharging airtime to your phone? We have a very simple approach here, whereby you have to go to your M-Pesa, Lipa na M-Pesa, then pay bill number is 737356 as displayed on the board. Then the account number now is your phone number, be it Airtel, Telcom, Safaricom. You just enter the phone number as the account number. Then you proceed to enter the amount, you complete the transaction, and you receive your airtime instantly. Remember, you can also purchase for a friend, whereby you enter the same pay bill, 737356, then the account number becomes the phone number of that particular friend that you're purchasing airtime for. You enter their number, the amount that you're surprising them with, then you complete the transaction, they will receive the airtime instantly. So thank you so much for always using this facility. Remember to continue using it. Back to the paper now, number 6. Triangle ABC such that A is negative 3, 2, B, 2, 2, C, negative 2, 6. Find the coordinates of its image after translation. Os vector T equals to 5 out of 3. Very simple. Very simple. So we're supposed to know that when we take the translation vector and we add the object, and the object should be put as a column vector, not as a coordinate, we get the column vector of the image. So to begin with A, we say negative 3, 2. When we add 5, 3, the translation vector, we are getting the image of A. So the image of A shall be, this is a 2, this is 5. Yeah. When we take 2, 2 for B, and we add the vector, translation vector, we shall get 7, 5. This one is B. Then when we take negative 2, 6, and we add 5, 3, the translation vector, we are getting C. We are getting C prime, whereby this is a 3, 9, that way. So with this now, we can analyze now and have them as coordinates. A prime, 2, 5. B prime, this is 7, 5. C prime, this is going to be 3, 9. That's simple. That's simple. So that's how we get the coordinates using a translation vector. Very simple work. Very simple work. Number 7, this is from one work. The figure below shows incomplete prism whose cross-section is a trapezium. We can see a trapezium ABCD, which is now the cross-section. Being a cross-section means even the other end, we should be having the same cross-section very well outlined. We should be able to see in the other end of the solid a trapezium cross-section. So cross-section is a uniform area which cuts across the whole length of the solid. So the length of the solid is BG, and the cross-section area is the trapezium that we can see. So to complete the solid now, you have to join That's right. Right. Then the upper part is wing. Then a uniform length. So at that point now, we can indicate the length that we cannot see clearly using dotted lines. Right. So we can name this solid according to the letters of alphabet used. We are already having a B, C, D. So we can have E, F, G, H. That way. So we can just follow the order of the alphabet. So you see, once we declare that ABCD is the uniform cross-section, we should be able to see another trapezium, which is HGFE on the other side. So throughout the length, cross-section area is usually maintained. So complete the figure and show hidden edges using broken lines that way. So we should have broken lines at that point. And also AH should be broken because it's a three-dimensional diagram that way. So it's a broken line also. So that's how we get the diagram. Very decent. So ensure to have a similar diagram whenever you're given such a question. I'll be looking at your comments. I want to see your suggestions. I want to see what you need to be done next. But remember, section 2 is coming after this section 1. Number 8, simplify 2x power 3 plus x power 2 minus 15x divided by 8x power 3 minus 50x. Let's deal with the numerator first. What is common in the numerator? We factor out x first. We are remaining with 2, x power 2 plus x minus 15. It's now a very simple quadratic expression whereby we can say we need a product of a times c. That is a product equal to negative 30 and a sum of 1. Two factors. When multiplied, negative 30. When added, positive 1. These are 6 and negative 5. Their product is negative 30. Their sum gives us 1. So we can talk about x into 2x squared plus 6x minus 5x, then minus 15. That way, we have replaced x with 6 and negative 5. You know, the meaning is retained. The value is retained for that expression. 2x, so that will remain with x plus 3 minus 5x plus 3, that way. So at this point, we can say from, you know, we have the initial x here, then from within the brackets, we are having x plus 3, and outside the brackets, 2x minus 5. That way. So the numerator is fully factorized. Now we can check what the numerator has for us. Let's check what the numerator is having for us. Check what the numerator is having for us. From the numerator, we can factor out maybe 2x, yeah? So that will remain with 4x squared minus 25. Yeah, 4x squared minus 25. Now, from inside the brackets, you can discover that we are having what you call a difference of two squares. A difference of two squares. Now, with a difference of two squares, let me give the general expression that governs how to factorize a difference of two squares. Assume you're having x squared minus y squared. That's a difference of two squares. Both numbers being subtracted, or both terms being subtracted, are having perfect squares. A perfect square, so they have perfect square roots. To go about it, you just need x minus 1, then x plus y. That way, the square roots added, then subtracted. So at this point, we can talk about 2x. Then we have now 2x minus 5 and 2x plus 5. That way, we will have factorized the difference of two squares, and the denominator is fully factorized. So now we can look at a combined expression, x plus 3 to x, sorry, extract that here, to x minus 5 out of 2x to x minus 5 to x plus 5. With this, we can talk about now what is common here. You can see this is common together with this, so that one factors out. And also x and x cancels out, such that outside the brackets, what we're having is a half. So we'll talk about x plus 3 out of, there is a 2 here, that way. So this is now the simplest form of the above expression. Don't be tempted to open the brackets and start saying 4x plus 10. Please don't open the bracket. We need the simplest, not the expanded. So this one is simplified and becomes our final answer. Wow, number 9 is a question on geometry. Using a ruler and a pair of compasses only, construct triangle ABC in which the length AB equals to 4 centimeters. Then the angle ABC equals to 120, and the other angle ACB equals to 15 degrees. 15 degrees. Drop a perpendicular from C to meet AB produced at P. Measure the length of CP. Measure the length of CP. All right. So we do that now. Slowly, we construct the triangle that we need. Sorry for all this interference on my screen. Sorry for that interference. Yeah. Number 9. The first thing to do is we'll draw the length of AB. The length of AB is equal to 4 centimeters. We measure 4 centimeters here. A, B, 4 centimeters, already measured. Then now we are supposed to measure some two angles here. The angle at the angle at B should be 120. So to measure 120 means you just extract 60 degrees. And remember, we are using a pair of compasses and ruler only without engaging the protractor. So we are supposed to construct an angle of 60. An angle of 60 on the outer side by standing at B. Let me show you how to construct 60. So you stand at B and you make an arc. Then now you stand on this arc and you cut the upper side. Now when you join that arc, the intersection of that arc with B, you will have come up with an angle of 60 degrees. So you construct 60 degrees that way. Yeah. This is 60 degrees. Then automatically now we are having 120 degrees. It's on the inside. You have to be very creative. With that, we can also talk about the angle at C being 15, but we don't know where C is. So the angle is supposed to be 15 degrees. That is to mean inside this triangle, because the total is supposed to be 108, then we can get the angle at A. So the angle at A is supposed to be, we take 180 and we subtract 120 and 15. Yeah, 180 minus 120 and 15. This gives us exactly 45. So the angle at A should be 45. When the angle at A is 45, the angle at C automatically will become 45. So we stand at point A and we start by raising a perpendicular that way. Then upon raising the perpendicular, we are again supposed now to bisect this angle. Once you bisect it now, you will have obtained 45 degrees, and automatically the angle at C will become 15 degrees. So we make an arc and an arc here. Then standing on those arcs, we make some other arcs. At you join. Sorry for that. I think I didn't manage my space very well. But anyway, we must come up with the actual diagram. Yeah, that way. So what I want you to understand is that the intersection there becomes our point C. You should be able to coordinate that. If we have 120 and the automatic 45 here, then automatically this now becomes our 15. The 15 we were talking about, we've not even constructed it. It has fitted in very accurately that way. Now, other instructions are telling us to drop a perpendicular from C to meet AB at P. So we have to produce AB so that we drop a perpendicular. We extend AB towards the right that way, so that when standing at C, we can now drop a perpendicular. So we have to stand there at C and you make arcs here. Then standing on those arcs, you can stand on this arc, you make another arc up there. Stand on this one, you also make another arc. So when you join that arc with point C, you will get a very perpendicular line. This is P now. So we have to measure the length of CP. Measure the length of CP. When you do it accurately, you shall have 9.5 centimeters. But remember, the examiner will allow some accuracy such that from 9.5, a student may have an error of plus or minus 1 centimeters. So 9.4 will be treated right. 9.6 will be considered to be right. But be at the exact. When you work it accurately, you will get the exact. There is a number 10 here. There is a number 10, which is on mathematical tables now. Use squares, square roots, and reciprocal tables to evaluate. 3.045 squared. So square tables. The first thing that we're using is the square tables. So we're going to square 3.045 square tables. Let's go there and squares. Square root, then squares. Which one comes first? Yeah, squares. So square of 3.045. 3.0, then 45. So 3.0 is here. We first identify the row. So this is the row we are dealing with, 3.0. Then 4, 5. So we go to the column that has 4. It's here. Column that has 4 is here. So that is the value we want. Then we go to the different side, whereby we're going to add the column that has 5. Check where the column with 5 intersect with the row that we are dealing with. This point. So we are adding 30. So 9242 plus 30. 9242 plus 30 that way. So we're getting 2729. So 9272. 9272. This is after squaring what? This is the value of 3.045 squared. We got the answer now. Then the other thing will be, we are finding the reciprocal. But before the reciprocal, let's talk about the square root. You know, the square root is of 49.24. 49.24. So let's check what square root of 49.24 is. 49.24. So we go to the square roots now. 49.24. Square roots are here. 49.24. So this is the row. This is the row that we are dealing with. Now we establish the columns that we need. 2 and 4. 49.24. So point 2 is at this point. So is at that point. So we check where it intersects with the row that way. And remember, for squares, for square root, we are starting with 7 point. So 7 point 7.0143. 7.0143. 7.0143. Then we are adding what? It was 4. Now we go to 4. The column that has 4 is 1. There is a 28 there. So we add 28. We add 28. So 28 should be brought at the end here. So that this is 1, carry 1, 710, 7.0171. 7.0171. That is after squaring. Yeah, that's after squaring. Then now we should know that we are dealing with. Let me narrow down the question now. We have already squared. Sorry. We have already squared 9.272 plus 1 out of. We have already obtained square root. We have already obtained square root. So now we are finding the reciprocal of that square root now. That will be the last thing to be found now, the reciprocal. Remember, we are supposed to use all the tables. So the table of reciprocal now is in use. 7 point. It is already starting with only one significant figure to the left, which is not even a 0. So we don't have to write any standard form. So we go direct to the reciprocal of 7 points. And remember, these are 4. We need to work with 4SF. Therefore, we are finding the reciprocal of 7.017. We find the reciprocal now. So this is going to be 7.017. So reciprocal. Let me check the reciprocals. Should be somewhere before. Yeah. 7.017. 7.017. 7.01. So it's 0.1427. Then here, the differences are subtracted, not added like in the other table. So we subtract whatever is at 7. So the column that has 7, you can see there is a 1 here. So we subtract 1 at this point. So it will be 0.1426. 0.1426. That way. So at this point now we will talk about 9.272 and we add 0.1426 that way. So this is 6, 4, 1, carry 1, 4. This is going to be 9. So the answer is 9.4146. That is the final answer. Yeah, that way. So you're supposed to be very conversant with the 4-figure tables. 4-figure tables. When you encounter values like this one, it's always advisable you round it to 4 significant figures because you cannot read anything for any number which is beyond 4SF. That's why we call it 4-figure table, because it deals with 4 significant figures. At 11 now, a cashier was given 115 notes worth 10,000 Kenya shillings in denominations of 50, 100, and 200. The number of 50 Kenya shillings, those were the notes, were 25 more than the number of 100 notes. The rest were 200. Find the total number of 100 and 200 notes. So we can let 100, let's, what's happening here? Let 100 notes be X. So that 50 notes become 50 notes were 25 more x plus 25. So that 200 notes become the balance. 200 notes are, the total notes were 115. When you subtract the one for 100 and the one for 50, will remain with the ones for 200. So for 200, we can simplify 115 minus, this is a 2x, and this is 25. So 115 minus 25, you see this is giving us 90. So 90 minus 2x, that is the 200 notes. So now with this expression, we can say, when we take the 50 by the number of notes and we add 100 times the number of notes, then we add 90 minus 2x times the value of these notes, which is 200, we should get 10,000 Kenya shillings. And from this now we can find the value of x. Aha, we can use this space just before number 12. 50x, 100x, and that's 50x plus 100x, but the other one will be now a minus 400. So I'm getting negative 250. Negative 250x. What about the other side? We'll talk about 2500. Then this is 18,000. Yeah, 18,000, 2500. Then we subtract from 10,000. So it will be 10,000 minus 2,500. 18,000. And that gives us negative 10,500. So that the value of x now becomes, when we divide this one by negative 250, you know, the negative will cancel and we get 42. So we're having 42 as the value of x, which means now if we are to divide these notes now, 50, okay, 100 notes, 100 notes are going to be x, which is 42. 200 notes, 200 shilling notes are going to be 90 minus 2 multiplied by 42, which is 172 notes. 174, sorry. And by the way, did I subtract well? Really? 90 minus, then I get a bigger value. No, I'm supposed to check that again. 90 minus 2 multiplied by 42. You see, this becomes only 6 notes. 6 notes. Then 50 bob notes are going to be, 50 bob notes are going to be, the expression is here, 42 plus 25, giving us 67 notes that way. So these are the number of notes for every denomination. The number of notes for every denomination. Please be exposed to these word problems. You will really enjoy mathematics if you can interpret the language used. You really enjoy. If you can interpret the language used, you really be in a position to enjoy everything. Yeah, that way. Now let's check our next question, which is number 12. Again, a very interesting question. Look at this. A fruit dealer blends the fruit juice in a common container to the brim before choosing the quantities in which to distribute them. She can pack them in either 20 liters, 24 liters, or 36 liters can before selling them. If she chooses 20 liters, the 20 liters can, she remains with 13 liters, while when she uses 24 liters, 17 liters remain. In a container, in the container that is, and 29 liters remain when she distributes the juice in 36 liters can. Determine the capacity of our container in liters. So she's having a big container, and from that container, she can pack the juice in either 20, 24, or 36. Let us check first which common container can be filled by 20, 24, and 36. And that becomes now the least common multiple, because we need something which can be divided uniformly by 20, 24, and 36. So the LCM of 20, 24, and 36. 20, 24, and 36. 20, 24, and 36 that way. So 2, we start with the least prime factor, 10, 12, and 18. By 2, we'll get 5, 6, and 9. By 2 once again, 5, 3, and 9. Then now we can go to 3, whereby this remains 5, 1, 3. By 3 again, 5, 1, 1. Then after this now, we can talk about 5 itself, 1, 1, 1. So the LCM equals to 2 power 3 multiplied by 3 squared multiplied by 5, multiplied by 5. We check that. 2 power 3, 8, multiplied by 3 power 2, 9, multiplied by 5, which is 360. 360, that way. But now, the container is a bit interesting. You know, when we divide by 20, we don't utilize all the juice. We will have 13 liters remaining. When we use 24, we don't pack all the juice. We will have 17 liters remaining. When we pack 36, you realize we don't pack all the juice. We will have 29 liters remaining. So something common is that you discover that whatever the container that we pick, whatever the can that we pick to pack these juices, there will be something common, and that is something common is remaining. Something common is remaining because when we use 20, we will remain with 13, which means there remains 7 to completely fill. When we use 24, there remains 17. That means there is 7 liters remaining to completely fill a complete can. When we use 36, you see there is 29 that remains, which means there is a 7 remaining to completely fill it. So there is a uniform 7 here. So when we take 360 and we subtract 7, we'll get 353, and that is 353 liters. This is the capacity of the container, the bigger container. That's why when you divide by 20, you'll get a remainder of 13. When you divide by 24, a remainder of 17, and by 36, a remainder of 29, showing that every time the next, or the amount remaining to completely fill a can is always 7. It's always 7 that way. So we get 353. Very simple question. Now at number 13. A chemist adds 60 cubic centimeter of solution containing 25% of water. If Y centimeters of the solution is poured away and replaced with the same amount of water, the solution is 50% water. Determine the value of Y. Again, a very interesting question. Let's get initial volume of water because the solution is having 60. So 25% in the volume of 60. 25% in the volume of 60, we are going to get exactly 15 cubic centimeters. So initially, there's 15 cubic centimeters. 15 cubic centimeters of water in this solution. Then we are saying now, y cubic centimeters of the solution is poured out. Y cubic centimeters is poured out. Then after pouring out, we say now that pure water is being replaced. Pure water is going to be replaced. So how much water is being poured out? Amount of water poured. Sorry, let me adjust this. The amount of water which is going to be poured shall be 25% in the y cubic centimeters. So 0.25 y. That is the water poured out. So amount of water remaining. How much amount of water has remained now in the new mixture? Still in the container before adding. Amount of water remaining. Remember, we were having 15, but now we are subtracting 0.25 y water. So the amount which is purely water is this one. 15 minus 0.25 cubic centimeters. Now, there is a new amount of water in this solution. New amount of water in this solution. Because now we are going to add replaced with the same amount of water. The same amount of water. Therefore, water added. The amount of water added is y. So new amount of water. New amount of water. This is after adding a y, sorry. This after adding a y cubic centimeters of water. New amount of water shall be 15 minus is the amount that had remained. But now we are adding y to this, which is purely water. So we will find that the new amount of water is 15 plus 0.75 cubic centimeters. This is the new amount of water. So now we are told that with all these now, the mixture becomes 50% water. With this amount, we are having 50% water. If it is 50% water and total volume equals to 60, then it means when we take 15 plus 0.75y, we should get 50% in the mixture, and 50% is 30. So 0.75y equals to 15. So that will remain with the value of y. Remember, we are just finding y. 15 out of 0.75. This becomes 20 cubic centimeters. 20 cubic centimeters. This one is the volume of water which was added, which is also the amount of solution which was poured out. The value of y. 20 cubic centimeters. Number 14. Okay, this again requires a very intense interpretation. Let me repeat it. A chemist had 60 cubic centimeters of solution containing 25 water. So we can calculate the amount of water initially because 25% is water. It means water initially was only 15. That is a quarter, 25%. So it was 15. Then we poured some amount of the solution. Remember, this solution being poured is containing both water and the other components of the mixture. So if we are pouring out Y, in that mixture being poured out, there is still a 25% being water. So 25% of that Y is water. 25% of this mixture being poured out is water. So that the amount of water that we have poured out. That means there remains some amount of water now initially. So the amount of water remaining is the total amount of water, which was 15, and now we have subtracted water together with some mixture, which is 0.25, the value of Y. Apart from doing that, we are going to add again an equal volume now. So Y again becomes purely water. So Y is purely water. So the amount of water, which is finally in this container, is going to be 15 minus 0.25 Y plus Y cubic centimeters, which are purely water. So that total water becomes this. Now, this is what forms 50%. And 50% in this container means 30. 50% in this container means 30. So 20% or 20 cubic centimeters. At 14 now. At 14, this is again a very interesting question. This is from Form 1. Angles and polygons. Let us look at it. We are told that an irregular polygon with n sides is such that 3 of its interior angles measure 144 each. The remaining interior angles measure 138 each. Determine the value of n. This question can be approached in numerous approaches. One, using sum of interior angles. You know, 3 angles are already measuring. 3 angles are already measuring 144. So 144 times 3 plus the others. The others are each 138. And how many are they? Total minus the 3 that we have already dealt with. This one will give us sum of the interior angles. And sum of interior angles can also be given by 180 into n minus 2. So this formula on the right-hand side is used for both regular and irregular polygons. So from this, we can get the value of n. This is our first approach. So we can multiply now. 144 times 3. This gives us 432 plus 138, the value of n, minus 138 by 3. This is 414 equals to 180 n minus 360. With this now, we can have arrangement of terms such that 180 minus 138, this is giving us 42n. Then on the other side, we have 432 minus 414 plus 360, because 360 will be added. We get 378. Then the value of n can be gotten after dividing this by 42. The value is 9. 9 sides. Very simple approach. We can check alternatively. method 2. So with method 2, we can say that for every interior angle, there is always a corresponding exterior angle, whereby if the two are added, they will give us 180. So at the point where interior angles are measuring 142, there is a corresponding exterior there measuring what? 180 minus 144, 36. There is an exterior angle measuring 36. Then for the others, which are measuring 138, when we take 180 and we subtract 138, we get 42. We get 42. Therefore, we say for every interior angle, there is a corresponding exterior, and exterior angles added up give us 360. So when we take 36 and we multiply by 3 exterior angles, and we add 42 multiplied by the remaining number, which is n minus the first 3 that we have dealt with, you see we are getting, this is giving us a this is giving us 360. So with this, we can talk about grouping of terms now. 36 by 3, this is 108 plus 42n minus 42 by 3, giving us 126. This is equal to 360. So that we can group terms by remaining with 42 here, n equals to, we take 360, we add 126, and we subtract 108. This is giving us exactly 378. You see now, n is again 9 sides. N equals to 9 sides. Very simple. 9 sides. That way. 9 sides. Number 15 now. Yeah, those are 2 opinions. By this, they can be even. There can be even some more. There can be some more approaches. Let's try a method 3. We just try in case it goes through. Well, method 3. Can we say this? That this particular interior angles should give us 360. They should give us 360. If they should give us 360, we have the first 3. The first 3 are measuring 36. So 3 times 36 equals to 3 angles times 36 each, giving us 108. So the remaining angles should give us 360 minus 108. 360 minus 108, giving us 252. Then with 252, we don't know the number of the other angles because the first 3 are giving us 108. The remaining ones should give us 252. So that when added now, they give us 360. So the other angles giving us 252, we don't know their number, but we know that each is having 42. We know that each is having 42. Therefore, 252. When we divide by each angle measuring 42, according to this here, each of them is measuring 42, but we don't know how many they are. Therefore, how many are they? Because they should give us a total of 52, and each is measuring 42. So how many are they? 252 divided by 42. This gives me 6. So we had the first 3 angles, and now the remaining ones are 6. Therefore, total shall be 3 plus 6, which is 9 sides. Remember, the number of angles, interior or exterior, is the same as the number of sides. That's simple. So you can see now we have provided 3 possible approaches to only one question. 3 possible approaches to one question. Very interesting. Number 15. In the figure below, AB equals to 15 centimeters. AC equals to 17 centimeters. You can see, according to the diagram, you can also see a right angle. BD is an arc of a circle, center A. Meaning that the radius is 15 and also 15 centimeters here, AD. Calculate the area of the shaded region. Calculate the area of the shaded region. Okay, to two decimal places, pi should be 3.142. Let's get the height first. We can start by getting the height. You can either get the height or the angle at this point, because area of a triangle can be used with the two sides and an angle, or with the base and the height. So let's apply any of those approaches to get the area of triangle first. Because for me to get the shaded region, I'm supposed to get triangle minus sector. Yeah, triangle minus sector. Triangle minus sector. Therefore, the length CB is going to be, according to Pythagoras theorem, 17 squared minus 15 squared. Then I carry out the square root. 17 squared, 17 squared minus 15 squared. Then I take the square root. This is giving me exactly 8. So this is 8 centimeters that way. So with that, we can now get area of triangle. Area of triangle ABC. This is going to be R base times height. So we need a half base times height. This is giving exactly 60 square centimeters. 60 square centimeters that way. 60 square centimeters. Now with area of the triangle, we can now talk about the sector. Area of the sector. The sector ABD. Yeah, ABD. We need theta. That means finally we have to get the value of theta. So theta over 360 pi r squared. So let's get the value of the angle at the middle. Now that for the triangle ABC, we are having all the sides and it is right angled, we are free to use any trigonometric ratio. So if this is theta, we can even use the tan of theta, which is given by opposite length over the adjacent length. So that the value of theta becomes the tan inverse of 8 divided by 15. So theta shall be shift tan 8 over 15. And this gives us 28.07. Yeah, 28.07. Therefore, now we can substitute 28.07 out of 360 pi, according to the instructions. Pi is already here, so you can't choose any other pi. R is radius of 15 squared times 15 again. So theta over 360 pi r squared that way. So let's get the area of that sector. 28.07 over 360 multiplied by 3.142 multiplied by 15 multiplied by 15. This gives us 55.12 square centimeters. So with area of the whole triangle and also area of the unshaded part, then we can get the remaining area, which is the shaded part. Now we need to get the total triangle, 60 minus 55.12. 60 minus 48.88. No, 4.88, sorry. 4.88 square centimeters according to the instructions, 2 decimal places. Yeah, 2 decimal places. So that is how number 15 was supposed to be done, with a lot of hope that you have understood what has happened in that particular question. So that's how it should be done. Good. Finally, there is a number 16 here, so that we may finish up with the section 1. This is a question on inequalities, linear inequalities. Unshaded region has already been displayed, and ours is to find the inequalities that satisfy the region R. So we can all see the region R, and we can also see the borderlines. So the borderline L1 is complete. So we use the inequality sign for will either greater than or equal to, or less than or equal to. Then when we look at L2, it's also a complete line. So it shall have less than or equal to, or greater than or equal to. But for L3, it's going to be strictly either less than or greater than, because it's a dotted line. So those are some of the basics that you should be having before you even approach the question. Good. So with this now, we can treat the borderlines as normal lines. Then we find the equations. Then after finding the equations, we can now establish the inequalities responsible. So for L1, we can see that, we use some red. You can see that there are some coordinates that we can pick from L1. So we can pick a coordinate at a point, any point like here. Those are 2 coordinates. That is, 0 is here. It's good you see where the axes are intersecting. 0 is there. So this is 1, 3. And another coordinate after 1, 3, we can talk about 2, 2. Yeah, 2, 2. So let's get this gradient now. Gradient 1 shall be 3 minus 2 divided by 1 minus 2. So this is 1 over -1. So the gradient is -1. If we are to write the equation now to be y equals to gradient -1 multiplied by x, then we add the y-intercept, which is 4. That is the y-intercept, 4. Y-intercept is 4. So we are having the equation already. I'm borrowing from the equations of straight lines, whereby y equals to mx plus c. M is the value of gradient, c is the y-intercept. So the gradient is already known. The y-intercept can be read from the graph. You can see where the line is cutting the y-intercept. So we can imply the equation directly that way. With this information now, we can establish the inequality responsible here. So we identify a coordinate which is within the region, within the required region. That is a coordinate 3, 2. So we shall use coordinate 3, 2 throughout. With coordinate 3, 2, we can substitute in the equation. Where there is x, we put 3. Where there is y, we put 2. So 2 equals to, okay, 2 on the right. Then on the 2 is on the, this y on the left. Then on the right-hand side, we have negative the value of x, which is 3 plus 4. This is -3 plus 4, which is 1. So we compare the relationship between the left and the right. Is 2 greater or less than 1? 2 is greater. So if 2 is greater, then the inequality symbol will be greater than or equal to. So for L1, we shall talk about y greater than or equal to -x plus 4. This is the first inequality. That is the first inequality. Let us check Let us check the second one, L2. Any two coordinates? Any two coordinates. I'm having some fixed coordinates at this point. That is a 7, 0 and 0, 4. 7, 0 and 0, 4. Yeah, 7, 0 and 0, 4. This means now we can get gradient by 0 minus 4, then 7 minus 0. This is negative 4 over 7 that way. We have our gradient. So now the equation is going to be y minus 4 over 7 multiplied by x plus 4, because the line L2 is also cutting the vertical intercept at 4. That way. Remember, with this, we can even multiply by 7 and have it as 7y equals to negative 4x plus 28. Yeah, that way. That it becomes an equation which is not having fractions. Now with this, we can use our coordinate again, 3, 2, so that you may see how the right and the left side will be related. So 7 and 2 because of y. The other side, we are having negative 4 with 3x plus 28. So this is 14. And on the other side, we have a negative 12 plus 28, giving us 16. So how is 14 and 16 related? 14 and 16 are related in such a way that 14 is less. And because the line is complete, then the equation shall be, the inequality shall be 7y less than or equal to, we include or equal to negative 4x plus 28. So that is the second inequality. This is the second inequality. Then finally, we have to come up with the third inequality. The third inequality now we consider L3. L3 is dotted. And we said it to either be greater than or less than, strictly that way. So now we have to think about two coordinates lying on this line. Two coordinates here can be, we have a coordinate here that is a 7, 3, a coordinate 7, 3. Then any other coordinate on the same line, coordinate at this point, that's 5, 2. These are coordinates with a positive gradient. So now we shall talk about 3 minus 2, change in y, 7 minus 5. This is 1 over 2. So the gradient is a half. So we can say, is the line cutting the y-intercept at some point? Yes. This is negative half. At negative half. So we will say y equals to half x minus half, which is our y-intercept. When we multiply by 2 throughout, we shall get 2y being equal to x minus 1. That way. So we can substitute our coordinate, which is within the required region, 3, 2. So 3, 2 means 2 by 2, 3 minus 1. So this shall be 4, and this shall be 2. The relationship between 4 and 2 is that 4 is greater. So because the line is dotted, then we shall stick at greater than. So we come to this and now substitute with our established inequality sign for 2y greater than x minus 1. Greater than x minus 1. That way. So we have the third inequality sample, the first inequality sample, the second equality sample. Remember, the inequalities can be in other formats. These are just my choice. So you can express it otherwise, as long as you shall maintain the meaning of the inequality. Otherwise, thank you so much. We'll be creating time for the wonderful section 2 here later. So remain subscribed to Shifting Grades Online School. Remember our consultation line 07 04153366. So this remains our consultation line. So thank you so much for being around. Remember, you can support our programs using the till number on the board, 49777742. Any amount is going to be highly appreciated. Thank you and all the best.